Hello and welcome to this video in response to the question, how do we differentiate tanh x when it is in exponential form? This video is going to be a little bit longer than it really needs to be because I'm going to answer this question and then answer it all over again. And to explain why I'm going to do that, let's refresh our memory as to what tanh is. Tanh x is sin x over cosh x. And the exponential form of sin is e to the x minus e to the minus x over 2 divided by cosh e to the x plus e to the minus x divided by 2. So the 2's cancel and we get e to the x minus e to the minus x over e to the x plus e to the minus x. But that's not normally how you will see tanh written. How you'll normally see it written is e to the 2x minus 1 over e to the 2x plus 1. And to explain why, let me fill in the middle step here. If you factorize e to the minus x out of both the numerator and the denominator, factorizing it out of the numerator, obviously you get the minus 1 here. Forcing it out of e to the x gives you e to the 2x. And the same on the bottom. You've got the plus 1 here, that's obvious, but forcing it out of the first term gives you an e to the 2x here. And then of course these two cancel. The reason I'm making that clear is because this little trick of factorizing might not occur to you to jump from here to here until you've seen it once. And that's exactly the same as something later in this video where the step might not occur to you until you've seen it at least once. It's not entirely obvious that that's what you should do. So the reason I'm going to do this twice is I'm going to do it with this one first, and then I'll go back and do it all over again with this one. This is more common. This one actually, in terms of differentiating tanh, is slightly easier. So how do we go about differentiating this? 2 steps to that. We need to do the actual differentiation, but then we also need to make it look like the result we expect. And the result we expect when we differentiate this is to get sech squared x. And it's that manipulation from the derivative into sech squared that most people will find slightly harder, because there's this little sneaky trick similar to this that is not immediately obvious. So let's go for it. We've got e to the 2x minus 1 over e to the 2x plus 1. And we want to differentiate all of this with respect to x. Now even here we've got 2 options. We can apply the quotient rule, or we could rewrite this as e to the 2x minus 1 times e to the 2x plus 1 to the power minus 1, and then apply the product rule. And which one you choose might depend on which one is available in your formula booklet. I think the UK formula booklet has the product rule in it, and the international formula booklet has the quotient rule, which is a little bit strange, but there you go. Either way, you'll get to the same stage. I'm going to use the quotient rule, which is to take the derivative of the numerator, so that gives us 2e to the 2x, and the minus 1 differentiates away to 0, and then multiply it by the denominator, and then subtract the opposite, the derivative of the denominator multiplied by the numerator, and then divide all of that by the denominator function squared. And if you choose to do the product rule, by the time you've differentiated, turned it back into fractions, and then combined those 2 fractions together, you'll get to this stage here. Now I'm going to expand the brackets. We get 2e to the 4x plus 2e to the 2x minus 2e to the 4x plus 2e to the 2x, and perhaps a little unusually, I'm also going to expand the bracket on the bottom. The reason for that will become clear in a moment. Plus 2e to the 2x plus 1. Then we can cancel these power 4x's on the top, combining the other 2 to give us 4e to the 2x over e to the 4x plus 2e to the 2x plus 1. And that's the differentiation section done. The question is, can we make this look like sech squared x? The answer is not very easily from this point. But there's this little sneaky trick that I've alluded to that once you've seen, you'll understand works, but might not occur to you until you've seen it. And it focuses on the idea that we don't really want this e to the 2x in the numerator, because if you do sech squared and you put that into exponential form, you get a 4 in the numerator by itself. So to get rid of this e to the 2x, we're going to need an e to the 2x in the denominator that we can cancel it with, and we can get that by factorizing it out of the expression. That leaves us e to the 2x plus 2 plus e, if we force it out of here, to the minus 2x, which doesn't look much better, but does get rid of that e to the 2x on the top. Now the second thing that might not occur to you, but which is very useful, is that this expression has come from a squared bracket. We've got something squared plus 2 times this, because this times this gives us 1 plus something squared. So because these two combine to give us a 1, this is 2 times these two, it has come from this bracket squared e to the x plus e to the minus x. And that's another step that simply might not occur to you, that this is the same as this until you've seen it done once. And on the top, of course, we've got the 4, and this can be written as 2 over e to the x plus e to the minus x all squared, and that gives us 1 over cosh all squared, which is equal to sech squared x as required. Now I'm going to do it again from the less common version of the exponential form of tanh, because that form does not require you to think about this sort of idea or changing this expression into this. So what we would have there is the derivative of e to the x minus e to the minus x over e to the x plus e to the minus x. And again, I'll use the quotient rule. The derivative of the numerator, the only thing that happens here is the e to the minus x brings a minus 1 down and cancels with the minus that's already there. So this actually becomes e to the x plus e to the minus x times by the denominator, which is the same thing, minus the derivative of the denominator, which has a minus come down at this point to become minus e to the minus x, times by the numerator, which is the same thing, all divided by the denominator expression squared. Now there's a bit more expanding brackets on the top, but immediately you can see already this expression is exactly what we want. We don't have to manipulate it. As long as we can cancel all of this to become a 4, we've got the same answer. So we've got e to the 2x, and then we've got a plus 1 plus another 1, because e to the minus x times e to the x gives us a 1, and this gives us a 1 as well. So we've got a plus 2, and then we've got plus e to the minus 2x, and you can probably see where we're going to get our 4 from, because the next one we've got almost the same. We've got a minus e to the 2x, and then we've got minus 2, but because of the minus in front, that becomes a plus 2, and then we've got an e to the minus 2x, and again, because of the minus in front, we've got minus e to the minus 2x, all divided by that expression, still squared. And here you can see that this one cancels with this, and this one cancels with this, to give us a nice 4 over e to the x plus e to the minus x squared, and this now is the same as we had before. Thank you for asking that question. I hope that is a satisfactory answer for you.